Okay guys, it is Christmas night and I took 2 naps today and my entire family is sleeping, so I decided to make y'all another video in case you wanted some more examples. Aren't you guys lucky? Alright, a May 2002 Gallup poll found that only 8%, so P is equal to 0.08 of 1,012 adults approved of attempts to clone a human. Alright, so part A, find the margin of error for this poll if we want a 95% confidence in our estimate. Well, so before I do anything, I should be, I should check the conditions here. So the first one would be independent. So you should say that there should be no reason in this National Gallup run poll, there should be no reason that anyone's answer influences anyone else's, so all answers should be independent. Random, it said in the setup that it was a random sample, so you'll quote that. 10%, 1,012 people should be less than 10% of all U.S. American adults, American adults, and then success failure condition. So 0.08 times 1012 is like 81 people, and so then same story, 0.92 times 1012. Both of those should be greater than or equal to 10, so I should be good to go on all fronts. Make sure you're really doing these and writing out the sentences, because the more shortcuts you take on your problems, the less you're going to be likely to remember this when it really counts. Okay, so A said find the margin of error for a 95% confidence interval. So 95, you've already done this, would be a z-score of 1.96. If you don't remember, you can do inverse normal of 0.025, and that's what you would come out with. Or you could look up 90s, or you could look up 2.5% in your table, your z-score table. Either way, you get 1.96. So we will want to do our z-score times p times q over n, and all that's under the square root. So that would leave me a margin of error of about 1.7% if I typed all of that into my calculator. Okay, B says explain what that margin of error means. Well, that's our 1.7 is our wiggle room. If I were to construct my confidence interval, I would start it at 8% and I would go out 1.7% on either end, and that would give me that I'm 95% confident that my interval with a width 1.7 on each side would capture the true population proportion if I could figure out what that was. So I am 95% confident that the true proportion of adults who approve of attempts to clone a human will be within 1.7% of my sample of 8%. Whether it be below or above, I don't know, but it'll be somewhere within 1.7%, top or bottom. Okay? Alright, C, if we need to only be 90% confident, will the margin of error be larger or smaller? So I'm going to be less confident here, so that if I'm going to be less confident, then I can miss more often, so that means that I could cast a smaller net and I would be okay with that. Yes, I'd probably miss more often, but that's what 90% confident means. So the less confident that I need to be, I'm going to have a smaller margin of error because I'm going to miss more often. So it was going to be smaller. D says to actually find that margin of error. So I'm going to flip to a new page and actually calculate that. Okay. Oops. So D. So if you were to go in your table or in your calculator and look up the z-score for 90% confident, it would be 1.645, and then it's the same P Q over over n, all under the square root, and that margin of error would come out to be 1.4%. So that's exactly what we said. It would be smaller. Your z-score is smaller, which produces a smaller margin of error because I don't have to be as confident. Okay, then we were talking about E. If everything stays the same, if we had a smaller samples, what would happen? Well, smaller samples means less precision. I have less data, so I am less sure. So if I want to keep my confidence the same, then I'm going to have larger intervals. Smaller samples means more variables, means higher margin of error. I do not know what's going on. I don't have as much information, so I need to have a wider interval in order to kind of make up for not having as much information there. So the more samples, the larger your samples are, you've got more information. You can have a small interval and be the same confidence level. But if you don't have as large of a sample, you don't know what's going on, so you need a wider interval to deal with that. Okay, a city ballot includes a local initiative that would legalize gambling. The issue is hotly contested, and two groups decide to conduct polls to predict the outcome. The local newspaper finds that 53% of 1,200 randomly selected voters plan to vote yes, while a college statistics class finds that 54% of 450 randomly selected voters. Both groups will create 95% confidence intervals. Without finding the confidence interval, which one will have a larger margin of error? Well, we just talked about this on the last problem. The newspaper sampled a large sample, and the college statistics class had a smaller sample. So because the college, even though we're keeping the confidence level the same, the college class had a smaller sample size, so they have less data, which means they have less precision. So they are going to have a larger margin of error to make up for that. The newspaper, they had a very, very large sample, so they will have a small margin of error because they will be more precise. Okay, so the answer to this one is the college statistics class. Okay, so B, find both intervals, which concludes that the outcome is too close. So I'm going to add an extra page so that we can work all this out from the beginning. Okay. All right, so first thing we would need to do is check our conditions. So we have our independent condition. So you would want to write all this out. You would say that there's no reason to believe that one randomly selected, I'll write it down. I can't really tell y'all not to be lazy if I'm being lazy. Good. Okay, so independent. This is two randomly selected polls, and one person shouldn't affect the other. The randomness helps with that. And speaking of the random condition, both polls were randomly selected. It said it in the problem. Okay, my handwriting is really not this bad. It's hard on this app. Okay, 10%. Okay, we don't know. We'll have to assume that the city has more than 12,000 voters because remember, which depending on the city, it could or could not, probably so. Remember that the one poll had 1,200, so if in order to make this flow, the city had to have 12,000 voters in order for the sample size of 1,200 to be enough. Okay, so for the success value, we're going to have to do it for the newspaper and for the statistics class. So for the paper, we would do 1,200, their sample size, times they got a 53%. So that would be 636. And then 1,200 times 47, be 564. Both of those are greater than or equal to 10. The stats class, they had a sample size of 450 and they got 54%. So their Q would be 46%. Either way, that's greater than or equal to 10. So all of the conditions are met. So remember, we have to name our what we're going to do here. So we're going to do a 1 proportion Z interval. Okay, so let's do both of those. Okay, so for the paper, remember they had a 53% sample population. We're doing 95% confidence interval. So P, Q, over they had the large sample size. So their interval would be 50.2% if you type it all that out. Okay, remember you type it out once with the minus sign to get the lower bound and once with the plus sign to get the upper bound. Okay, and then we have the stats class. So they had a 54%, still 1.96 because still 95% confidence. So theirs would be a 49.4% lower bound to a 58.6% upper bound. And then D was which one would have it too close to call. Well, that would be the statistics class would vote it too close to call because 50% lies in their margin. So technically they're not sure which way it would go. They're probably going to lean closer since most of the margin's in the 58, but because the 50% is within their margin, they're going to say it's too close to call. For the newspaper, their lower bound was at 50.2, so they're going to call it the in favor way. Okay, I'll see y'all next week.